welcome to True Projects. In this video, we are going to explain about the project that is MPD, a meteorological and pollution dataset, a comprehensive study of machine and deep learning methods for air pollution forecasting. So before getting into the execution, first let us understand what is the project about. So air pollution, it has become one of the most serious global problems directly affecting human health. Harmful pollutants like nitrogen oxides, sulfur dioxides, ozone, and fine particles such as PM 2.5 and PM10 are often present in much higher amounts than the safe limits suggested by health experts. When people are exposed to these pollutants regularly, they face a higher risk of chronic illness such as asthma, lung infections, heart disease, strokes, and even neurological issues. This is why millions of people die earlier than expected every year due to long term exposure to polluted air. Apart from harming human health, air pollution also contributes heavily to climate change by releasing greenhouse gases into atmosphere, and the situation is especially alarming in cities and industrial areas where pollution levels are consistently above safety standards. The World Health Organization has reported that over 99% of people across the globe are breathing air that is more polluted than it should be, which clearly highlights the urgency of addressing this crisis. Effective monitoring and accurate prediction of air quality have therefore become essential to protect both the human life and also the environment. Anyways, predicting pollution levels accurately is not easy because we don't always have enough reliable data. Setting up and maintaining air quality sensors is very costly, and since these sensors are spread out in limited locations, we don't get complete coverage of a whole city or a region. On top of that, the humidity, wind, and pressure in ways that are often non clear and hard to capture with simple methods. Because of this, traditional statistical techniques often fall short in making reliable predictions. And the another big issue here we have is availability of the datasets are often incomplete, unstructured or noisy, which makes it harder to train models that can generalize well. Without strong datasets, even advanced models struggle to perform consistently, reducing the effectiveness of pollution control strategies. This is why researchers are focusing on new approaches like advanced machine learning and deep learning models that can better handle these complexities and provide more accurate forecasts. Accurate predictions can then guide timely interventions, policies, and health warnings to protect people and the environment also. So, the proposed system is designed to predict air pollution levels using advanced machine learning and deep learning techniques. It combines widely used benchmark datasets with real Harley air quality data from Madrid. This approach ensures that the system learns from both the general patterns and local real world conditions. The datasets used in the system include not only the concentrations of different pollutants but also related factors like weather condition and traffic data. By considering these multiple aspects, the system can better understand what influences pollution levels and make more accurate forecasts. And here, the proposed system is structured around the three main experiments to evaluate its effectiveness. In the first experiment, the system focuses on predicting nitrogen dioxide, that is NO2. So it mainly focuses on NO2. So it compares simple traditional models like random forest, 2D regressor with advanced machine learning and deep learning models such as LSTM, CNN, attention based temporal graph convolutional neural networks, that is A3T GCN, and diffusion models. These comparison helps to determine which models are most accurate and effective for pollutant prediction. And second, the second experiment, it applies the same methodology to real-world air quality data from Madrid. This allows researchers to test how well the models generalize to different data sets and deal with real-world noisy and variability. Third experiment, it expands the system scope to predict forests to predict multiple pollutants simultaneously, including SO2, CO2, and NO. Here, multi-output random forest, multi-target XGBoost, and multitask deep learning models are used to forecast multiple pollutants at once, demonstrating the system's ability to handle complex multidimensional prediction tasks. So here, the system performance is evaluated using several standard metrics. That is RMSE, which is root mean squared error, MAE, that is mean absolute error, R squared, that is coefficient of determination, and MAPE, which is mean absolute percentage error. These metrics help to compare the accuracy of traditional models against the model, that is against more advanced spatio-temporal models, showing which approach predicts air quality more reliably. By using these evaluation methods, the framework ensures that its predictions are both accurate and consistent. This makes it dependable tool for short-term air quality forecasting, which can help in policymakers and also environmental agencies make informed decisions to protect public health and also manage pollutions effectively. Moving on, the system incorporates XAI and LimeShap to make model predictions understandable. So just by implementing these models, we don't know why that model has taken that decision. To know that, as an extension, we are incorporating Lyman Shap, which are explainable AI models to make the model prediction understandable. These methods show which features like meteorological conditions or pollutant levels have the most impact on the forecast. This transparency helps users trust the predictions and also make better informed decisions. And also, we have developed a web interface using Flash framework. It includes user authentication, so only registered users can log in, enter input data, and also receive predictions from the trained models. This makes the system not only interpretable but also easy and safe to use in practical settings. Moving on, to implement this project, here are the steps which are followed. So let's understand them and see how this project has been implemented. So in the first step, necessary Python libraries are imported into the project environment. These include libraries for data manipulation like pandas, numerical operations like NumPy, and for visualization tools like Matplotlib and Seapon, and for machine learning and deep learning frameworks, scikit-learn, TensorFlow, and PyTorch. Then comes data collection. So here, the Madrid Harley dataset has been loaded into the project. So the project uses Madrid Harley air quality dataset, which contains detailed pollutant measurements and related information. So these datasets are loaded into Pandas data frame, which makes it easier to process, analyze, and manipulate the data for further steps. Then comes data pre-processing. So here, the data pre-processing ensures that the dataset is clean and ready for modeling. Here, timestamps from the dataset are converted into proper data time, that is date and time format using FECHA and HORA columns. And in the next step, categorical features like MUNICIPCIO and ESTACION and localization are encoded into numerical formats so models can understand them. After that, missing values that we have in the dataset are handled using methods such as interpolation and forward filling to maintain continuity. And in the next step, pollutant values are normalized using min-max scaling based on domain-specific ranges to standardize data. In the next step, lag features are generated for the previous 12 hours to capture temporal patterns and labels that are created for next 12 hours to enable prediction. And coming to the fourth step, so here we will be training the models on different experiments. So on experiment 1 for predicting NO2 pollutant, we are using these models. That is LSTM, CNN, A3T, GCNN diffusion model, random forest 3D regressor. And we apply same thing to the matter data set. After that, we will be applying all these machine learning models for predicting all these pollutants. So we will be using multi-output random forest, multi-target XGBoost, multi-target deep learning models. And we will be evaluating all of them using these metrics, and we select the best performing model and save it for the future use. And we explain the model's predictions using Lyman Sharp techniques. And we have developed front-end using Flash framework, which also includes user authentication where only registered users can log in. And in the front end, they will be able to give the input that will be pre-processed at the backend, and trained models will be predicting the pollutants as per Harley basis. And coming to algorithms used, these are the algorithms used from machine learning, and these are the algorithms used from deep learning, and these are the spatiotemporal models used. And to implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview. Now let's get into the execution. To execute, let's open the code folder that contains source code files. So these are the source code files, and this is the code folder of the project. And here in these two folders, we have the dataset that is used in this project. And this is the models folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And this is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests and interacting with the database and generating dynamic content to be rendered in HTML templates. This is the Jupyter Notebook file, which contain a combination of code, graphs, outputs all in one place. It allows users to write and execute code in individual cells. This is the database file. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I have copied it. Now open Anaconda prompt. So give the command cd, give the space and paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. So here we have given wrong command. Give the proper command. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So just wait for a while. File is being compiled. At this address, application has been hosted. So this is the local host and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I've copied it. I prefer Google Chrome, so I will paste it in that. So paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get signed up first. Click on sign up and enter all the credentials. That is all the details to create an account. So I have already created. I will directly sign in. Click on sign in. Give username and the password and click on login. So we have logged in successfully and redirected to prediction page of this project. So this is the prediction page. Here you can see different pollutants, right? So these are the pollutants and here we have pollutant for each hour. So these are the pollutants for each hour. And there are so many things that are to be entered. So it will take so much time. That is why we have created an option to generate sample data randomly. So if you click on generate sample data, it will create a random numbers for every pollutant for every hour you can observe, right? So if you want, you even can increase that value or you can decrease it. So for example, let me show you. So here you can increase and here you can decrease. Any value you can increase or decrease. So after generating sample data, you need to select a model. So let's select random forest first. Now click on forecast. So here, first we have air quality index, which is 6.54, which is predicted as good. And here we have forecast table for the next 12 hours of all the pollutants. So for hour 1 of SO2, it would be 33.6. Accordingly, for all the pollutants, for all the next 12 hours, it is predicting the pollutants. And here we have that graph. So here you can see graph, right? On x-axis, we have hours ahead and on y-axis, we have concentration. So this is next 12 hours forecasting graph of random forest. So it is predicting next 12 hours pollutants. Each color represents one type of pollutant. And here we have graph. So as we are using ML, that is Madrid area dataset, that is why it is locating that area. Now let's get back. So click on try prediction. Now let's generate random sample data. It is generated. Now let's select the other model. So let's select the 2D model. You can increase or decrease for the values. Now click on forecast. So here we got the prediction. That is the air quality index, which is 2.5431, which is very low. So that is why it is predicting to be hazardous. And here we have forecasting table for the next 12 hours of pollutants. And here we have forecasting graph of the 2D model. So these pollutants are predicted by the 2D model. Now here we have location map of Madrid location. So it is predicting that is these pollutants, these air pollutants are of this area, that is Madrid. Now come back, click on try prediction. Now generate sample data and select diffusion model. Click on forecast. So here we have the prediction. You can observe, right? Here we have the prediction for the next 12 hours. And here we have air quality index that is 54.48, which is moderate. It is moderate level. And here we have forecasting graph of diffusion model. So this is how you need to execute. Now let's check with the graphs. Click on graph. And here we have the graphs. This is the MSC graph of all the models. Here on x-axis, so here on x-axis, we have all the models that we have trained, and on y-axis, we have mean squared error. Close it. And here we have RMSE. So this is the RMSE performance comparison graph. So here also on x-axis, we have all the models, and on y-axis, we have RMSE score. That is RMSE error value. And this is the Sharp value of random forest, which shows the feature importance. So this is the Sharp value. Close it. And here we have MAE. This is mean absolute error. And here we have R square. This is R square. Close it. And here we have line plot of metrics. Open it. This is line plot of all the metrics. So each color represents one type of metric. Blue represents MSC, orange represents RMSC, red represents R square, and green represents MAE. Now close this. And here we have R square comparison graph, that is stacked bar graph. And here we have Sharp for 80 GCN model. So these are the feature values. Now close this. And here we have waterfall plot of all the metrics. So here we have waterfall of all the metrics. Now close this, click on sign out. In this way, the application will be able to accurately predict the air quality and also the forecasting for, that is forecasting of pollutants for the next 12 hours by using machine learning models and the deep learning models, which are random forest, 2D, and diffusers. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.